So Chapter 8, Quantities in Chemical Reactions. I skipped section 8.1. I can't remember exactly why, except that I had a good reason. So 8.2, making pancakes. Relationships between ingredients. We've been talking about chemical equations. We talked about what they are, how to balance them, the different kinds, how to predict products, all that stuff. Now we're going to look at what we can use that chemical equation for. The chemical equation gives us relationships between quantities of reactants and products. And those relationships are called stoichiometry. So this chapter is a lot about stoichiometry. This allows us to predict how much product we'll make if we have a given amount of reactant. And these types of calculations are really, really important. Okay? So I just told you the whole gas evolution reaction, you could get along without that. Stoichiometry, you cannot ignore this. This is really, really important, very central to chemistry. So let's talk about making pancakes. Hopefully everybody had some lunch. A recipe is somewhat like a chemical equation. It gives us relationships between the ingredients and how much of the finished product we're going to make. So here's an example of a recipe for pancakes written in the form of a chemical equation. 1 cup of flour plus 2 eggs plus half a teaspoon of baking powder yields 5 pancakes. Now, I don't recommend actually trying to make pancakes with that recipe because they're missing a couple of things, but it's good for illustration. So the ingredients are flour and eggs and baking powder. And the product is pancakes. And here we have pictures. 1 cup of flour, 2 eggs, half a teaspoon of baking powder, and we end up with 5 pancakes. So if we have 2 eggs and enough of everything else, we can make 5 pancakes. That's what the recipe tells us. And we can write that out as a ratio. We can say for every 2 eggs, we can make 5 pancakes. Or we could say that 2 eggs is equal to 5 pancakes. Now, does that mean that 2 eggs are the same as 5 pancakes? No. In this situation where we are making pancakes, 2 eggs means that we can make 5 pancakes. It's the equivalent of 5 pancakes. Well, what if we have 8 eggs? How many pancakes can we make? What if we need more than 5 pancakes, right? Some of my people, they can eat 5 pancakes by themselves. That's not going to cut it for the whole family, right? Well, how could we figure that out? Well, we could do it more conceptually and say, okay, well, there's 2 eggs, that'll make 1 stack of 5 pancakes, and here's 2 eggs, that'll make that stack. Those 2 eggs will make this one, and these 2 eggs will make that one, which is great if we have nice whole numbers and everything and are dealing with things that we can visualize. But how could we do that using math and dimensional analysis? Well, 5 eggs. 5 eggs. How do I do that? That's an 8. 8 eggs. I had 5 pancakes on the brain. And we want to figure out how many pancakes. So dimensional analysis tells us that we should multiply by the number of pancakes, the unit that we're trying to get to, the quantity we want, and we're going to divide by the number of eggs because we want eggs to cancel out. And then we look at the recipe, the equation. What's the relationship? Well, you get 5 pancakes for every 2 eggs. 8 times 5 is 40 divided by 2 is 20. Any questions? So however many eggs we have, then we could figure out how many pancakes could be made, assuming that there's plenty of everything else.